Good morning, everybody. My name is Ethan Rinauer. I am an educator for the Artesian Alliance, which is the Cheehaw Park and Zoo, the Flint River Aquarium, and the Thronatiska Heritage Center here in Albany, Georgia. Today, I am coming at you from the Flint River Aquarium because I want to talk to you guys about swimming. Swimming. You think swimming and you're like, oh, okay. So you're going to talk about fish, right? And the answer is yes, but also a lot of other things too. Just like every other kind of motion that I've mentioned here, it's kind of a broad one. Swimming, it's a very, very broad kind of motion. And so there are a lot of different ways that animals do it. So we're going to look at a few of them. And to start, I'm going to share my screen with you guys, and I'm going to present. So there's a lot of different ways that animals swim, all the way from the smallest animals to the largest animals. In fact, quite literally, both the smallest animals, the tiny little bacterial cells that are just single-celled organisms, and the largest animal, the blue whale, the largest animal to have ever existed. Both ends of those spectrums, both of them swim. Swimming is probably the most common kind of movement, actually. There are so many creatures that swim, and they all swim in just slightly different ways. So we're going to look at a few animals that swim. We're going to look at photos. We're going to look at videos. And I even have an example of a swimming animal just right over here to the side that I will show here near the end. So the first creatures that I want to start with the very smallest creatures, the very smallest animals that we have. There are two different kinds of swimming eukaryotes, just tiny little bacteria. Ciliates and flagellates. Now, both of them technically use the same method for swimming. If you see, they've got all these little fine hairs, or in this one's case, it's got this one very long hair. Ciliates are ones that have little flagella known as cilia all over their body, and then they basically just sort of waggle it, and that's how they get around. And they'll just waggle it around until they bump into something, and they'll either eat it or sometimes they might absorb it, but these guys will eat things because they're consumers. And then you also have flagellates, which are ones that have a very long, sturdy rudder, and they'll use that. They'll undulate it, which is, you know, going back and forth, and that's how they will propel themselves forward in water. So even the very smallest creatures use it. In fact, if you had a microscope and you have water, I guarantee you, you will be able to see both of these guys probably swimming around in, say, like stream water, if you take that and look at it under a microscope. So let's get a little bit larger now. Let's talk about invertebrates. Invertebrates don't have a backbone, so it's any creature that does not have a backbone. So the two examples that I have on this page are crayfish. If you've ever seen crayfish swim, it's kind of fun. They will flick their tail there, and whenever they flick it, they'll push that water forwards, and so they'll actually go backwards. So if you can picture that, like imagine that this is a crayfish, it'll flick itself and flick itself, and so it actually swims backwards, which is a great defense strategy if you're trying to avoid something in front of you, but not a particularly great strategy if you're trying to avoid something behind you. So use it how you will. Other creatures, such as the jellyfish, float through the water and do basically nothing. Some of them have slightly better control, so they might be able to sort of push water outwards and kind of use it as a jet propulsion system, a very slow, basic jet of water, but a jet all the same. Other jellyfish have no control, and so they will just float however the ocean currents take them. So that is kind of technically a form of swimming. I actually have, if the video will work, yep, I have an example of a very weird method of invertebrate movement. I took this video just the other day of our octopus here at the river aquarium. And let's see if the video will work all right. It was being a little slow this morning, but hopefully it will start here in a moment. But octopus are a type of cephalopod. Other kinds of cephalopods are things like squids, and actually all mollusks have what's known as a siphon, which they will use to propel themselves through water. The octopus's siphon is, if this is the octopus right here, do you see its head? Behind its head right here is where its siphon would be. So if it wants to move really quickly, it'll stretch its arms out and it'll just shoot itself by using its powerful muscles in its head. Well, its mantle. This is all its mantle. This is its head, but it'll use its powerful muscles in its mantle to just push itself, just basically squeeze water out of that siphon like a jet. And it's really having a hard time playing. There we go. So this is another method that squids or that octopus use. And there you go. Oh, you got a really good view of its jet right there. That's its jet. And so you can see that it was using it to move away. But if it's trying to move in its closer motion, it will actually just use its tentacles to sort of grab and pull itself. And actually, octopus have been known to use 2 of their tentacles to basically walk across the ocean floor. Let's take another look at its siphon here. You'll see whenever it jets backwards, it'll use its siphon. So octopus and other cephalopods actually also jet themselves backwards. So things like squids will. So you can see it was taking in a bunch of air, or I guess water, a bunch of water. And now it's shooting them all out to get away from me a little bit more because it decided I wasn't interesting enough. So cool. So that's an example of another kind of movement. You actually saw a couple different kinds of water movement there, but the big one is its siphon, which is right where its head meets its body, which is above it. And it'll shoot water out of that siphon and kind of move backwards that way. There's a couple different kinds of propulsion in fish. And I know this isn't a fish. This is an Amphiuma, which is a type of amphibian that has tiny little limbs. It does have limbs. It just doesn't look like it does. But bicaudal fin propulsion, I have a couple examples of it here, including this fish. Bicaudal fin propulsion means that basically its whole body, its 2 caudal fins, move. So it kind of undulates its whole body here. So bicaudal fin fish will be very narrow, usually, and they will wiggle their whole body to move themselves forward. So let's take a look. This is not a fish, obviously, but these guys also use their whole body to sort of move themselves forward. Let's see if he wants to do it. I couldn't get a really wonderful video of our Amphiuma doing it, but you know, he's trying. But he will use his whole body to wiggle himself. Another example of bicaudal fin propulsion is actually, there we go. Actually, our clownfish here. A lot of reef fish do it. So you'll see. Do you see how he's using his entire body basically to propel himself forwards? That's how a lot of reef fish do it, because their bodies are really thin, so they will wiggle themselves all the way forward. So they'll use their whole body to propel themselves forward. So he's kind of using his fins to steer a little bit, but the main power comes from his tail there. You'll see a lot of great examples of it in actually Finding Nemo. Dory is a great example of a bicaudal fish because she's got those that very slender, narrow frame to help it wiggle itself forward. So bicaudal fin propulsion is really great if you're very small. It tends to get a lot harder as you get bigger, because the bigger you are, the more muscles you're going to need to move your whole body like that. So whenever you're smaller, you can sort of wiggle yourself around and move pretty quickly that way. It also helps in places like reefs where you have to be small and narrow and fit through cracks and stuff. So it sort of developed both as a mechanism for swimming and as a mechanism for evading predators. There we go. Another kind of swimming is median paired fin propulsion, which is just a really long way of saying they use their side fins as their primary method of movement. So two examples of fish that mainly use their side fins are pufferfish and most all rays use it. So if you've ever seen a ray move through the water, they're moving steadily along, and they're kind of pushing themselves forward with their side fins by undulating them back and forth here. That's true with pufferfish as well. So they will move their fins, but they won't rely on a back tail. In fact, rays don't even have a back tail. They've just got that really long steering rudder. They have that long tail that they use as sort of a rudder to help them steer, but they mainly propel themselves along by waggling their fins. So whereas these small little reef fish were using bicaudal motion by using their top, basically both their top fin and their bottom fin as sort of a rudder for their entire body, these guys are using their side fins as a rudder for their entire body. To propel themselves forward. I don't have a good video of that, but let's go back one. Hydrofoils is the third big kind of movement for fish, and actually you can see it in other animals like dolphins as well. Hydrofoils usually have their fins sort of near the bottom like that. They usually have a nice big dorsal fin, and their bodies tend to be very slender. And I like to think of them, they kind of remind me of like a supercar, right? Where they're really just designed for speed. Hydrofoils are very quick. They essentially use their bodies like an airplane uses it to lift off. So whenever airplanes are lifting off, they're putting negative pressure above the wing and positive pressure below the wing. So they're putting different levels of pressure, and that pressure actually ends up pushing the wing up. They basically use the same sort of method. So under their fins, there will be a different pressure than above their fins. And so it'll help them to move forward. And I'll show you what I mean here. A lot of sharks are hydrofoils. I said dolphins are hydrofoils already. And we have a great exhibit here at the Flint River Aquarium called the Blue Hole, which simulates these natural springs that we get all along rivers like the Flint River and the Muckley here down in southern Georgia. And we have a whole bunch of fish here, and I want you to try to identify different methods of swimming here. Pay especially close attention to our sturgeons, because our sturgeons are hydrofoils, believe it or not. You see how they've got this big dorsal fin here and these caudal fins that help them move forward. So they're essentially just propelling themselves forward slowly with that water, and they're using their fins to help guide them, and they're changing the pressure above and beneath to make them just sort of cruise forward with as little effort as possible. You might notice some of our other fish moving around here too. Some of these really small ones, like that one's demonstrating bicaudal motion right there pretty well. You can see how they've got these very large caudal fins, and so they use it to help them propel themselves forward. Other fish like this one are also using more of a hydrofoil kind of method. So they're undulating their back to propel themselves forward, and they're using their fins to steer. We've actually got some turtles right here. So that's another method of movement that we are going to talk about a little bit more here in the future. But man, I don't think this video ever gets old. We could watch it forever and identify different kinds of movement in our fish here. All the way from this massive sturgeon to these striped bass to a couple of the bluegills and other fish that are using a little bit more of a different method here. They're all moving themselves forward by just slightly different methods of swimming. I bet you whenever you look at fish, you don't really think about how each of them has sort of their own unique way of moving forward, but they do. They really do. These tiny little fish move forward in a completely different way than these larger fish like the sturgeon. All right, I'm gonna pause it here. We might look at it again because it's just so much fun to watch, but we've seen a lot of different kinds of motion there, including the sturgeon, which is a hydrofoil. So there's another method of swimming called drag-powered swimming, and it's whenever you are essentially using the drag to propel yourself forward. So drag is what happens whenever there's friction, right? So these fish and other creatures, like I have a water boatman here, will use the fact that water has a lot of friction to it and basically push themselves forward using the water instead of trying to slither their way and undulate their way through water. They will instead push upon it. So water boatmen, if you've ever seen a water boatman in the water, a tiny little water bug, they push themselves forward across the water, just underneath the water. Some of them go along the surface of the water, but they still propel themselves forward with water. And seahorses also do this. Seahorses will push themselves forward using water. They're actually a very slow fish. And if we go back, I'm sure we can find some examples of this as well. Maybe in some of the smaller fish. Let's see. Maybe not. I don't know if any of these fish do. I know those turtles did, but I'm not going to wait to see these turtles again. Some fish do it, other fish don't. But they push themselves forward instead of relying on undulating back and forth to get themselves to where they need to go. They instead just literally push the water. So there's a lot of examples of creatures that do that. Even crayfish kind of do it. They just do it in a slightly different way. And another method that I want to talk about here is flippers. So using flippers to kind of get yourself going. And actually, there's a lot of different creatures that use flippers, from things like sea lions to sea turtles over here. They use flippers to move themselves forward. So what they will do is they will push themselves forward with their flippers, and they will instead of fish which undulate side to side, they tend to push the water just like that drag method that I mentioned before. And even whales, larger whales, their back tails are up and down, so they use up and down motion to get themselves going. And so they will also rely on flippers depending on the kind of cetacean, which cetaceans are whales and porpoises and things like that. Another method of movement is it's very similar to flippers, but have you ever seen like ducks? They paddle using their flippers in the water. A lot of creatures that aren't fish tend to use different drag methods where they're relying on pushing the water instead of just sort of motioning through it. And actually, I have an example of a creature that uses some special kind of flippers to get itself going here. Let me see if I can have it. Oh man, he's not happy with me. He doesn't like being out, I guess. But this guy is a yellow-bellied slider, and he's called a yellow-bellied slider because of that yellow belly he's got there. And they're called sliders because what they'll do is they will sit on like logs and rocks and the edges of streams. And if they see prey or they feel threatened, they will slide in to the water. And he doesn't really want to show them off today, but If you see his hands, his front hands have these claws on them, which help him sort of dig into the ground to catch prey. And his back legs, which I'm not sure I'm going to be able to show off. Oh, yeah, he's showing them off a little bit. His back legs are covered in flippers. He's got webbed feet that help him to move forward. So he's got these webbed feet that help him to move forward, and he's got these front legs that help him push forward. And he's actually doing it right now. This is exactly what he would do in the water: is push himself forward with his back legs, and then he would kind of use his front legs and his head to steer, and he uses his tail to steer a little bit too. And these guys, believe it or not, have the exact same motion that, say, a bird would have flying through the air. So their back legs actually function a lot like bird wings to propel themselves forward. These guys are considered some of the most efficient propulsion based swimmers in the entire world. They are extremely, extremely good at propelling themselves forward here. Now, he is an unhappy fellow, so I am going to put him back here. But turtles are actually extremely efficient swimmers, pretty much all turtles, except for tortoises, which generally live on land. But turtles tend to be extremely, extremely efficient swimmers. And they will push themselves forward, just like he's doing right now, to try to kind of get off of me, because he doesn't really appreciate that I'm doing this right now. But he will propel himself forward using his back legs, his powerful back legs, and then he will use his front legs to sort of maneuver himself as he goes. So I am actually going to set him back down, push him away here, and turtles are extremely efficient swimmers. Other examples of swimmers that propel themselves with their legs like that are things like, things like terrapins, which are very similar to turtles, but are slightly different. They propel themselves forward with specialized webbed feet. And actually, some aquatic mammals like platypus have webbed feet that they use to propel themselves forward. As I mentioned, ducks have webbed feet, geese have webbed feet. Creatures like that tend to have webbed feet that help them move forward. So you get a lot of different methods of swimming from all of this. So let's go back to this here, and maybe you can see these turtles again as we're watching. So what we're not showing down here is actually there are some catfish near the bottom, and catfish also have their own method of swimming. They will sort of wriggle and propel themselves forward with their sides. So they do a little bit of both, bicaudal and the other one, which name's escaping me, median paired fin propulsion. So they will use that. And then there's hydrofoils as well. I actually have another example of an animal that propels itself forward. This one might be a little bit more cooperative than my yellow-bellied slider here. So I'm going to grab him real quick here. All right, so hands are wet from grabbing him. Oops, sorry, we're just having a little bit of a hard time, some technical problems here. Stop sharing. Sorry about this, we're just having some technical problems because my hands were a little bit wet, so it made it hard for the touchpad. now I can't see myself at all. There we go. Finally. All right, so this guy's a little more cooperative. This is actually a map turtle, and they're called map turtles because if you look at all of these unique and delicate stripes and the patterns on his back, it kind of looks like a map. Map turtles are also found around here, just like yellow-bellied sliders are. And this guy doesn't really want to show them off much, but he's got very similar powerful legs. Maybe you can see them a little bit here. You can see this is actually his whole foot right here. It's just poking out. And he's got this little head and he's tucking himself in. So what they do is they will sit at the bottom of streams if they think they're threatened, and they'll just look like a rock. Like this guy looks a lot like a rock, so he'd be really hard to see. He's got that nose that tips upwards so that he can, if he really needs to come up for air or anything, he can. And he's starting to come out a little bit. Maybe he'll poke his legs out. I'll be able to show them off a little bit more. But in a very similar vein to yellow-bellied sliders, he'll use his back legs to push himself forward with those webbed feet. There he goes. Look at those webbed feet. See those webbed feet? They're very, very excellent webbed feet. I was hoping he would do that. See, because he can't see my hand holding him, he was thinking that right now would be a great time to make a break for it. And he is still working through some stuff here. So he is an excellent swimmer. We've talked about different kinds of swimmers. We've talked about bicaudal fin motion. We've talked about median fin propelling, so things like rays, which use their fins to propel themselves forward. We've talked about hydrofoils, which are pretty cool. Things like dolphins and sharks, and even our sturgeon use sort of a hydrofoil method. And we've talked about other animals which swim as well, so like the octopus and other cephalopods, which use their powerful siphon to propel themselves forward. We've talked about turtles, which have these excellent back legs that push water behind them and move forward. And we've also talked about some other creatures which have slightly more unique ones, like bacteria, which have flagella that help them propel themselves forward, and crayfish, which just use their really powerful tail to push themselves backwards. So that is all of the methods of swimming that I could think of. There are tons of different methods, and animals use extremely unique ways that they can get around. Like even creatures like snakes and eels just sort of undulate themselves around to where they get to where they need to go. So that's all I have for you today. So I hope you have a good day, and I hope you learned a little bit about fish and how they swim around and how other creatures get around as well. Have a good day.